science booster. It is the idea of running a science bus. Sorry, it's in German. Of buying, equipping, and running a mobile laboratory. Yeah? And the keyword is a kind of living contact between science, teaching, and information and service to the population, to the parent generation. So there is a kind of initiative in Austria going on called Sparkling Science Project. I'm currently running one with the School of St. Pölten, where we study floodplain areas and the dynamics in floodplains. What this idea is heading for is a permanent sparkling science activity. Yeah? Permanently available to bring students to the field, to have a look how scientists work, being involved with their own questions, but also if other people want to get involved locally, they can go there. Well, in the US, these initiatives are basically run by universities. They have this buses. They are climatized, fully equipped laboratories in buses or trucks. And this is how we think such a mobile learning and research unit would look like. Well, to keep the story short, for a pilot, as we are from the new research center in Thurn, and we are analytical chemists and also soil scientists, we thought it is good to start with something combining these expertises. Just take one of these cards. This is the soil here in Klosterneuburg, and kind of soil outside where I'm working in Thurn, where we have sediments from rivers. So it's a bit different. And there is also already a big initiative in Lower Austria. All these areas, and also Klosterneuburg, participates in this initiative of our soil. Yeah, we love it, or we stand on it, as we say. Yeah? And this guy here is measuring by X-ray refraction method the elemental concentrations in the soil. This is equipment we have set up here. Yeah? So people go out there and measure elemental concentrations in everything that could be measured in principle. And the idea is not only let students run around in the field, because there was already a presentation of a colleague called Learning by Doing or Doing Without Learning. Yeah? So there is also this kind of understanding that sometimes students do something but they don't really get it finally what it was for. We want to frame the whole exercise, as it was already described by the chemist teacher here, with the scientific method, where we start with some curious thing that comes to the mind of the student or is available from a scientific project, go into the literature research, create a hypothesis, plan the experiment, or make the measurement and analyze the data, and finally communicate, write it up in a proper way. Well, we don't have the bus here, but imagine we are going outside now and getting some soil samples from a contaminated site. Yeah? Getting there, doing kind of CSI, chemistry science investigation in this case, and start the measurement. And I would like now the students to start the measurements, and there is another colleague.
Change with the machine out there. Is that okay?
No? Yeah, if it is possible?
Yes, it's possible.
Yeah. Well, you can already start with taking the soil samples that we have prepared. And we start with the measurement first of some, you can come here. Come here. And what we are online doing here is we have created, so we have to remove this. We have created a spreadsheet for cadmium, copper, lead, nickel and zinc that already compares the measured values. We do 4 samples per site, with some value, with a critical value, yeah, and you get the result online. So, a question to you: what hypothesis do you have for this soil?
We thought that the soil in Klosterneuburg would contain a much lower concentration of metals or kind of contaminated substances than elsewhere.
Okay, okay. So let's prove that. If the soil here is less contaminated. So start with the first measurement. And what we see here is it measures now for 30 seconds. Here we see the parts per million or microgram per gram content of the contaminants in the soil, which is from Corinthia, which is an area where they have got, yeah, it's contaminated. So we will see, we will then see the. So there was mining activity in the past, and all the stuff is still lying around them. And they have also a natural elevated level from the geological background. So it mixes up there. I have another soil here. We're not measuring it from Burgenland, where we have a naturally higher elevated level in zinc. No, but the next time you are allowed. Yeah. Ah, okay. Yeah, so the next time you are allowed to bring your samples. So we have 30 seconds measurement time per sample, and for a simple statistical reasons we do 4 per site, so we get some results out of that. And what we already see is here that we are running into a problematic concentration with copper, lead, nickel and zinc. And if you scroll out on the right side a bit, then you also a bit more, then you see also the critical value for Lower Austria, which is from the Umweltbundesamt, from the Federal Agency of the Environment, and you see that we are far off this allowed concentrations. We have another, the second one, and this is the soil we got from the school garden. Yeah? So we hope that this soil garden is no contamination. Otherwise, we have not done a good job. So what you already see is, and this is something very important, that students get involved in kind of statistical analysis very, very early in when they're analyzing things. Can you tell us something about how could we probably, let's say, charge the difference in the mean values between the contaminated site and
we have the standard variation or the t-test.
Yeah, we have a t-test. Yeah, what is a t-test?
There you compare the different standard variations or the standard mistakes or Fehler.
And the mean values. Yes.
And the mean values, yeah. And down there we have a chart. It's not full now, but
yeah.
You
so
can
this,
compare them.
yeah. So this
Yeah.
chart, and we have discussed already before what type of error do we use to charge the difference visually.
Yeah, we have just standard. And if you can put it 4 times to the next point and one to the other value, you can see it here. About 0.1 or 0.0.
Yes. So what we already have discussed is that we can visually charge the differences in mean values using the standard errors and not the standard deviation.
Yeah.
Very often people use standard deviations to charge probably differences, statistically significant differences. This is wrong. You cannot do it. You can just charge the disperse of the data. 95% are within 2 plus minus standard deviations. And with these simple tools that are pre-programmed more or less, you can introduce easily statistical principles. You can make students thinking of the appropriate tests they want to use. And finally, we already have discussed, it would be nice, there is something existing out there, a kind of guidance which test to select for a specific situation or so. So student, what kind of samples do you have? What do you want to run? And then you get out some kind of statistics. Okay?
Aber der Standardfehler ist auf den Mittelwert immer bezogen, oder?
Der ist auf dem Mittelwert, ja?
Auf den Mittelwert, da kommt es natürlich darauf an, was ich für einen Bereich habe, wo ich messe.
Sag's dann.
So kann ich dann natürlich auch leicht variieren. Wenn ich einen Kalibrationsbereich habe von 0 bis 100 Milligramm, ist was anderes,
Yes.
als wenn ich habe von 0 bis 1000 Milligramm.
Yes.
Weil da
We are
kann
talking,
ich nicht
yeah,
Fehler oder
yeah,
Fehlermodell.
yeah. We are talking now about the error propagation probably already in chemical analysis. So what we are here doing finally is just comparing values. Yeah, so we are not now in the error propagation in chemical analysis, but that would be the next step. And clearly you can see that this is combining expertises, cross-curricular discussions taking place by doing that. And that's very important, I think. Yeah.
May I take over for one sentence?
Yes.
So the goals we have, first will be to approach in iTEC. So outcome of iTEC, I think, will be nice going in this presentation. And second goal we have is now you designing Austrian central final exams, because all students up from next year will have to write a pre-scientific work before doing the final exams, and we hope that this will be the basic of written works based on facts, based on practical work. Thank you.